Welcome back to the fourth episode in a series where I'm doing a total rebuild on my CNC3018. In this episode, I'll be mainly focusing on the hardware related to the lead screws, so let's get into it. So as you've seen in earlier episodes, I've been actually mounting the stepper motors using standoffs. Now I do that to ensure that we get the maximum amount of travel in any of the specific axes. And as you can see there, I'm already making a mistake. I actually forgot to tighten up that lever on the tailstock to stop the drill from moving around. Anyway, a bit of a noob mistake. And even here, I've still forgotten to do it. Later on, I realized what I was doing wrong, but anyway, that's what happens when you're not machining for a while. You don't have those things top of mind all the time. So the shorter spaces, the ones that go on the x-axis, I'm doing that in aluminium. And they're just straight drilled through, very, very simple. And I'm only going to show you me making one because obviously it's not that exciting. For the Z-axis, I'm doing that in brass, and I think I did it mainly because the color is sort of quite nice and it matches well with the Z-axis assembly. But also these standoffs have to be quite long, surprisingly long. I don't know why they designed that original Z-axis assembly like they did. In any case, to get the full travel on the lead screw, you know, it's like 30 millimeters, or as you can see, it's quite long. And so I thought doing it in brass would make it a little bit more rigid. In this case, I actually have to thread both sides of the spacer, so it's not just a drill through. And so I have to actually tap both sides. For the side that actually interfaces with the stepper motor, I'm actually using a cut-off piece of bolt basically, and just screwing that in there to effectively get the bolt end to screw into the stepper motor, and that seems to work quite well. Getting a good finished brass is always problematic with this mini lathe. It picks up every tiny little movement when you're working with brass, so you know you really need to get out the emery cloth if you want to have some sort of a decent finish. So that's one side done, and we need to finish off this other side. And tap it. And there you go. Yeah, I think it'll look really good. So next up we're going to be making this machine screw collar. It's written there as bearing stopper. Obviously I could have just bought these, but you know, why buy it when you can make it, I guess. So I decided to make them. They're fairly straightforward. They just need to be 8 millimeters precision drilled through. And they need a little step on the front end so that it only interfaces with that inner race. Otherwise, obviously, it's not going to work the way you need it to work. And it's lovely to see that I managed not to get the focus correct here. Obviously the camera preferred the high contrast of all the garbage falling down there on the bed. And to save a little bit of time, I decided to just try and cut two in one go, which worked out pretty good. So here's the step on the first one. We'll face off and step the second one. Yeah, really nothing complicated in this part of the operation, that's for sure. Just manually tap the screw here. I think it's M3 I was using. Maybe it's M4, I can't tell. Anyway, tap it and fuse it fitted with a grub screw. It's nice and easy. So this is a little bit more interesting. Here are the original knobs that I had on my first iteration of my CNC3018. They're just 3D printed with a grub screw. But I wanted to do these in metal. In this case, I decided to go with steel. And the reason I did that is because I actually am using it as a bearing in a race. And if I had done it in aluminium, it would have been, well, too soft, I think, because it's a very, very thin race. And you'll see a little bit later what I mean by that. And obviously, if I'd done it in brass, it's going to be too expensive. So yeah, steel it is. This is 30 mil, I believe, outer diameter. I'm just going to use the entire outer diameter and knurl it directly there. This is the first time that I'm using this knurling tool, and it's working really well. I'm very happy with it, even though I've got a bit of a janky sort of mounting arrangement. Cut in the chamfers. And now we've got to bore it right out to the depth we require for the lead screw. Now, and this needs to be fairly precisely created. As you can see, I'm here squaring off the bottom of the hole, but it's still undersized at this point. And the reason it needs to be quite precise is because it's going to be the inner race of a bearing related to the lead screw. So if there's any sort of offset or run out, it's not going to run true. So you can see it's quite a tight fit on the lead screw. So now we're going to cut the bearing inner race, or I think they call it a journal. I don't know what that even means, journal, but anyway. Yeah, you can tell I'm not a machinist by trade, that's for sure. We also need to create a step on this face as well, once again, so that we're interfacing with the inside bearing race. But we'll do that in a minute. First we've got to get it to fit, which it doesn't. But again, this needs to be super precise, so you know we're down to the level using emery cloth to try and just get it over the edge. Yeah, this is really tight. Now I'm using this bearing because this is literally the only bearing I had on hand. I think I probably would have just gone with the 8mm internal diameter bearing if I had one, but I didn't. So anyway, this worked out okay. So now hopefully we're going to get cutting that step. Doesn't need to be very big. I think it's around about 0.5mm is all I'm going for. Maybe less, 0.25. And here I'm just going to do a rough part so we can face the other side a little bit later. You can see I've got the live center there pushing just to keep it all stable while we're putting the pressure of the parting operation on it. There's quite a lot of stick out because I cut it quite long, this piece of material, because I reuse it later, as you'll see in a minute. And I can't part to the center because my parting tool is not long enough, so metal fatigue is the way to go. There we go. Now I'm going to mount this to a mandrel to finish the other side. The mandrel I made out of brass, so we need to tap this hole now for the grub screw. In theory, I probably should have put a grub screw on both sides, but anyways, it's quite a precise internal diameter on this hole, so I think it's not going to be that bad. Yeah, there we go. It turns out the chamfer on the inside here was a little bit asymmetrical, so just tighten that up a little bit there, make them look the same. And there you go, look at that, looks really good. Super happy with that. I even had my son make one of these while I was sort of directing him, and this is the one that he made, and he did pretty good. So I reckon if he can do this as a pretty much a, you know, someone with nearly no experience, you can do it too. So both on the X and the Y axis, we will be having that knob, and as you saw, we had that inner race. So we also need to make a housing for the bearing, for that same bearing that will go onto that knob as well. So that will go on the outside of the panels and house the bearing basically. Yeah, makes sense, right? So these are really quite thin, and that's because the bearing is quite thin. I think it's around 4 millimeters if I remember correctly. And as I said, I probably would have used a bigger bearing if I had one, but this is what I had on hand. But the upside is that it will be quite elegant from the outside. You know, you won't actually notice the bearing actually being there at all. So I think it works out okay. So naturally this internal diameter is the precision component, so you know we really have to fiddle around a lot here and slowly edge in to that final dimension. And it's just got to fit, right? Yeah, it looks good. It's tough to get out there. Just do a chamfer up front and a bit of finishing before we get into the parting operation. Now the finish on the part is going to be a bit, you know, whatever, it's not going to be great because I'm not going to be able to face it off all that well. I think that's okay. The external face will be clean. And here you can see I'm making a second part because, you know, we already have the right internal diameter, so we can take a second one. In fact, in total I make 3 of these parts with the leftover bit of material I had from making those knobs, so that worked out all right. The next tricky part is just sort of cleaning up this excess here. Probably could have just manually sort of filed off that internal bit of burr, but anyway, we'll line it up here and get a bit of machining done on it. Probably overkill. Anyway, it's good practice on technique, so try to figure out how to handle these really dicey situations. We're literally on just one tooth of that chuck jaw there. And I'm actually just manually doing the internal chamfer there. It's pretty tricky, but anyway. And there you go. And there's 2 of them that I've made. As I said, I've made 3 in total, but and the finish on the inside is, yeah, a bit rough, but it's okay. So only on the y-axis we actually need to make a inner bearing or inside of the frame bearing housing, and it looks a bit like this. We don't need it on the x-axis because I could actually reuse, and actually it's important to reuse the bearing housing that's built into the frame on the x-axis because we don't want to lose any travel on that x-axis. But on the y-axis, obviously the position of the lead screw dropped down a bit, and so that means that the original hole I had to sacrifice and it's gone. So the only way to now house the bearing, or the main bearing for the lead screw, is to make a separate housing, which is what we're doing here. The shape is a little bit tricky because I actually want it to be self-locating. I want to drill located, or I already have drilled locating holes in the frame. And so we need to have sort of a lip on the housing that will actually sit within the hole on the frame. Yeah, again, fiddling around getting these bearings in. Yeah, it's a little bit loose, but I think it's okay. I'm going to face off the back end and set the depth correctly, and we'll finish her up here. Nice little chamfer on the internal hole. This is a laborious part of the process because the parting tool in this configuration is really not all that stable in any case, because I don't have the ability to use that supporting rod in this configuration because it only works, I think, out to around about, I think it's about 15 millimeters in diameter when I'm using the insert style parting tool. So yeah, it's a bit tough. But persistence, and eventually you'll get there. So this is the ledge that will stick out and sit into the hole in the frame and locate it with relation to the frame. So it's a pretty important hole. It has to be fairly precisely machined. Finish off the internal face. Chamfer up, finish her up. We can get on to parting it. Now this time it's probably a bit more important to mount it in the lathe to finish it up. There you go. Very nice. The bearing fits. Yeah, I think pretty good fit. So again, I'm using 3D printed jigs here. And I'll be using those so I can accurately drill a location of the holes on each of these housings. And for the case of this housing, I actually have to file down the top here. And I've actually got that in the 3D printed jig here as well to locate or accurately try and file down that shape. I'll just pick a good side to file down. Yeah. So I don't think this part requires much explanation, so I think I'll just let you watch. Now we got to file down this piece of the top here, okay? Get it all nice and level, same height on each side. Looking good. And the height, yep, it's okay. All right, last little bit of tidy up. Yeah, really super pleased with that. Look at that finish, really nice. So I'm going to drill and tap M2 size bolt holes here. I did actually manage to snap off this tap, so it's sort of like a half-length tap. Anyway, stuff happens, right? For some reason I had the great idea to get out the impact when this was getting a bit tough to actually screw them in, but the problem was I managed to snap off the heads here. The screws that I was using were just too long, so it was just a stupid mistake. So yeah, anyway, don't use the impact on an M2 screw, not a good choice. Anyway, no harm, no foul. I managed to recover this pretty painlessly on this particular case anyway, and use the shorter screws here, and yeah, that's fine. Now for this other housing, we need to open up the locating hole, hopefully relatively precisely. Yeah, pretty tight, and since you lined up with that edge well there, so hopefully the location is going to be pretty precise enough. So I have this little locating pin which I machined with two different sizes because the internal diameter of both bearings are different. And I need to get the location as precise as possible. Mark up these holes. And I think I'm tapping these with M3, a much larger screw here. And I'm not going to show you me tapping every single one because I have to do this process over and over again. It's quite annoying. Locate it with the drill press and then manually send it home. So they're all done there, and I also finished the internal panels here, these aluminium panels, with a brush style finish, just like I did with the outer panels that you saw in the last episode. And the external bearing housing, I use that locating pin again there to try and keep things in the right position. So let's try this out. Get the knob on there. Try and cinch it all up. There it is. Voila. I think it looks really good. No movement whatsoever, and it's freely moving, so look at that. No movement whatsoever. And the x-axis housing, etc., is pretty much the same thing, so I'll show you an abbreviated version of that. And obviously we don't have that internal side housing because we're just using the housing that's already built into the frame itself, so it's a lot simpler. Made a bit of a mess on one of those screw holes with the way that I located it, but it's okay. So we'll try it out, stick the bearing in there. I think we're done. Yeah, much the same. It's moving freely. And there's no in or out movement there at all, so yeah, give that a pass. So I decided to heat treat all these parts to try to, reduce the chance of corrosion. Unfortunately, my torch I'm using here is a little bit underwhelming, but good enough for that little piece. Some of these bigger parts took a real long time, and I really couldn't get them up to the heat I really wanted to, but I mean, they got red hot, so I guess that's good enough. But yeah, next time I'll probably be using 2 torches at the same time with these large parts. Yeah, not really a bright red, but good enough. And obviously things boded even worse for these fairly heavy knobs. I really had the heat going here for a long time before they finally got even a slight sign of going a bit red. But yeah, patience. I wish I had a stand or something there to hang it in front of the heat because my arm was getting pretty tired, that's for sure. There we go. And yeah, that'll do it. And obviously I did the rest of the parts too. I'm just showing the 3 different types that we're working with here. So fish them out. See how we did. This fishing expedition is a little bit tricky actually. Go. So there it is. 2 knobs. 3 outside housings. You can see one of those outside housings is got a bit flaky, but overall the finish is pretty good. I'm not actually going to try and rub the finish off. I think maybe just leave them as they are, see how they wear. Looks pretty tough. Obviously I'm just using normal motor all this time, so that seems to have worked well. Yeah, looking good. So that's pretty much going to be it for this one. A little bit of a longer episode than usual, but heaps of good progress all the same. I do look forward to seeing you in the next episode where I will be making some precision homing sensors for the CNC. So I hope to see you then.